Unit 6, Day 2, First Differences and Graphing Relationships. So let's look at a few definitions first. So a linear relation is one in which the points lie in a straight line. The graph below is an example of a linear relation. As you can see, the points definitely lie in a straight line. The second definition is first differences. So these are the differences between each of the y values in your table of values. We'll now go into some examples that use both of these definitions. Example 1. Calculate the first differences for the given data and graph the data. So we have a t-chart here. So to calculate the first differences, we're going to create a new column called delta y, which stands for the differences in the y values. And to calculate the difference in y values, we take the second y value and subtract it by the one before it. So for these two, it would be 4 minus 2, which is equal to 2. These two, it's going to be 3 minus 4, which is equal to negative 1. 6 minus 3, which is 3. 9 minus 6, which is 3. And 11 minus 9, which is 2. And those are the first differences for this chart of data. And here's the data on a graph. We have simply taken the x and y points and plugged them into the graph. Let's now calculate the first differences for this table. So we have 1 minus 3, which equals negative 2. We have negative 1 minus 1, which equals negative 2. We have negative 3 minus minus 1, which is also equal to negative 2. And we have negative 5 minus minus 3, which is equal to negative 2. So all the first differences are equal and they are negative 2. And here is the associated graph for this table of values. Again, we have simply plotted the points x and y onto this graph. And finally, let's calculate the first differences of this table of data. So we have 5 minus 11, which is negative 6. We have 2 minus 5, which is negative 3. We have 4 minus 2, which is equal to 2, and we have 11 minus 4, which is equal to 7. Notice all the first differences are different values. And here's the final graph for this table of values. So in summary, how can we tell whether a relationship is linear or not based on the table of values? So hopefully you've picked up on a pattern. If the first differences are constant, so they're all the same number, the relationship is linear. So if we scroll back up, this example here, all the first differences were constant, they were all negative 2, and if we look at the graph, it's a linear relationship. And finally, if the first differences are changing, the relationship is non-linear. So if we look at the other two examples, these first differences are changing, and this is definitely non-linear. Let us now look at a few more definitions. So variables are values that change in a relationship. Independent variables are variables whose values change on its own accord. So time, absolutely nothing else influences it, it just changes on its own. Dependent variables are the opposite. So they are a variable whose values change based on the independent variable. So for example, the height of the sun in the sky would be dependent, and it depends on the independent variable, which is time. A couple things to note: in a table of values, the independent variable is placed in the left column, and the dependent variable is placed on the right column. In a graph, the dependent variable is placed on the vertical axis, and the independent variable is placed on the horizontal axis. So knowing those 2 points, hopefully you guys can connect and think, okay, the independent variable must be the x, and the dependent variable must be the y. Same as here. The dependent variable is placed on the vertical axis, so the dependent must be the y, and the independent variable is placed on the horizontal, and we know that is where the x goes. Let us finish with an example. So the cost of a banquet at Jory's Banquet Hall is $450 for the room rental, plus $15 for each person served. So part A, identify the dependent and independent variables. The dependent variable is going to be whatever changes based on the independent variable. The cost is the dependent variable because it is changing based on the number of people that show up or that are served. So cost is the dependent variable, and the independent variable is equal to the number of people. So nothing influences it. It happens on its own, and then a reminder that the dependent variable is dependent on it. Part B, create a table of values. Here's the table of values that we have created based on the scenario that we have. So we've decided to increase the number of people going up by 10, and the total cost is always going to be $450, so that base fee, and then $15 times the number of people that show up. So for 0, it's just $450. For 10 people who show up, it's $450 plus 15 times 10. Part C we'll do up here. So they're asking us to draw the graph to see the relationship. So here we have plotted the graph, and we can see the relationship between the points in our t-table. So for part D it says, is the relationship linear? Explain. Yes, it is definitely linear because all of the points form a straight line.